Thank you, folks. What a pleasure to address an audience of this caliber, and I thank you for this opportunity. I won't say anything really any more about the working tracks since we just covered those in great detail, but I certainly thank the organizers of those for all the work they put in. Also, of course, Les Johnson and all the organizers of this event from TVIW, Tau Zero, and Starship Century for the huge outlay in time and energy they devoted to what we have done in these days we've had together. Sometimes, somewhere around the 6th century BC, a man named Lao Tzu, an almost legendary philosopher and writer, purportedly produced the book known as the Tao Te Ching, a fundamental text of Taoism and Chinese Buddhism. This year's Tennessee Valley Interstellar Workshop arrived made to order for Taoist thought with its theme, Step by Step, Building a Ladder to the Stars. Because for years, I have used as the line on my digital signature the Tao Te Ching's aphorism, you accomplish the great task by a series of small acts. Confucius, who may have known Lao Tzu, would echo the same philosophy. Well, as anyone paying attention to this year's sessions learned at the beginning, many of the acts we are trying to accomplish are anything but small. A 100 gigawatt laser array is not small either in concept or in physical dimension. A sail 5 meters to the side is small by many earlier standards, but what we discuss doing with it, a mission to the nearest star, is not small, nor is the exploration of the outer solar system with precursors fueled by fusion or driven by plasma sail a small accomplishment. But conceptualizing each of these things, one at a time, that is a series of small steps, and we need many such small steps. The emergence of Breakthrough Starshot clearly changes the game for everyone in the interstellar community. We have a congressional subcommittee report that, and I'm quoting here, encourages NASA to study the feasibility and develop propulsion concepts that could enable an interstellar scientific probe with the capability of achieving a cruise velocity of 10% of the speed of light. Now, I doubt seriously that phrasing would have emerged without the powerful incentive of the funding provided by Breakthrough, nor would the Tau Zero Foundation's recent grant. We are on new terrain. We're a long way from where we once were in the days when there were few interstellar meetings as such, and most discussions among those of an interstellar bent happened at occasional get-togethers and meetings on largely different subjects. Today we have a community, and if it is one with a pointing problem, in terms of how often it meets and how well it stays focused, it is at least one with high energies and a steep drive to succeed. TVIW 2017 gave us a range of focus sessions, which I've chosen to group, trying to avoid being too arbitrary, into loose themes. Pete Klupar gave us the Breakthrough Overview, which includes the welcome and related work of both Breakthrough Watch and Listen, a reminder that we must gain more information about the targets of our missions, and indeed decide whether there may not be an even more attractive target near Centauri A and B than Proxima. The welcome news that the RFP process has begun with work on the project's laser array shows us a community with an actual interstellar project seriously defining the parameters of a mission. Here we are in the larger realm of vision, as Andrew Simeon reminded us when he tells us that we search for ourselves as we venture to the stars. We also, whether or not we send Starshot sails on their journeys in 40 or 50 years, define the limits of our present technology and infuse the entire enterprise with an unprecedented prospect of well-funded trade studies. The interstellar enterprise advances whether or not Starshot sails launch to Centauri. And who can say what spin-offs we won't gain from the effort in the interplanetary arena with Starshot's tools. On the matter of overview, let me mention Mark Millis's discussion of the Tau Zero grant from NASA, which, as I mentioned, derived from the impetus of the Starshot initiative. Comparing propulsion approaches to take us through what Millis calls the era of precursors, the era of infrastructure, and the extrapolatable future, and I knew I would stumble on extrapolation there, helps us identify the critical issues that need study, just as Starshot itself helps us to locate, one by one, the major problems we need to solve for a specific mission concept. What we do need to be wary of is premature lock-in for doing interstellar missions of other kinds with competing methods very much remain on the table. In the realm of hard decisions and trade studies that illuminate them, Kevin Parkin showed us a system models that allows Starshot to study not only a Centauri mission at 20% of the speed of light, but also a precursor mission to a closer objective and a 70 kilometer per second ground vacuum test. It is heartening to realize that Parkin's system has already been used to conduct trade studies since March of 2016. Meanwhile, the inputs from the broader community continue. Al Jackson showed us an analysis of trajectories for a Starshot probe, and we're reminded by Benjamin Diedrich, who has been working with the NEA Scout mission, that we can learn much from a mission with a much different objective, and one with the ability to apply guidance and control forces that our Centauri-bound sail will be unable to muster. Congratulations to Diedrich, and particularly Les Johnson, for the recent successful deployment tests of the NEA Scout sail. I want to also mention, in the realm of trade studies and laboratory work, the importance of the kind of measurements George Hathaway discussed for any work of this kind. Looking at problems in testing high voltages and high vacuum at cryogenic temperatures, Hathaway showed the measurement pitfalls that can ensnare experimenters. Hard lessons to be kept in mind at all times by those who are evaluating propulsion technologies both understood and exotic. Starshot's mission and components were a major factor in all our deliberations. That 100 gigawatt laser array that Robert Fugate described can put something on the order of 30,000 Gs on the sail if we can get it to operate, despite major issues of laser phase noise, optical path length differences, atmospheric fluctuation, and pointing accuracy. We are considering a sail that goes from Earth orbit to 10 times the distance of the Moon in a matter of hundreds of seconds. Can we make this happen? Starshot fails if it does not. And it fails if Jim Benford and those working with him cannot come up with a sail that can withstand the huge forces to be slammed into it. Now, here I want to pause just to mention the rich background on display at the conference in sail technologies. The Benford brothers did the first work on sails in the laboratory, and as far as I know, the first actual tests of beamed sails, some 16 years ago. In the audience, we had Greg Matloff with us, a distinguished figure in sail history, who has been examining their prospects for decades. Jeffrey Landis has published key papers on sail materials, and although his role in this TVIW was to discuss the solar gravity lens, his contributions help us as we look toward possible sail materials and shapes within the Starshot envelope. The welcome presence of Giancarlo Genta reminds us of the tremendous contribution of the Italian sail effort through Project Aurora and other work in the 1990s. Greg Matloff referred to that at one point today as well. The need for the kind of sail test facility Jim Benford so carefully described is obvious, and one hopes it will be the target of quick action, especially with the new wave of RFPs starting to translate the concept into reality. Phil Lubin's analysis of directed energy as the enabler for interstellar missions, beginning with the NIAC Phase 1 study under the name Starlight, led to Pete Warden's making the connection with sails as a possible driver for a Centauri mission with a wafer-scale payload. I'm sorry that Mason Peck wasn't here to participate in this discussion. He has done so much for this spacecraft on a chip concept through his work at Cornell. But Lubin reminded us that an infrastructure like this can do much more than drive chip spacecraft. It can become a huge factor in planetary defense, in power beaming to Earth, space debris removal, and beamed transport within the solar system. Giancarlo Genta presented a preliminary analysis of inflated spherical sails of the kind recently proposed by Avi Loeb and Zach Manchester for Breakthrough Starshot. Working at far lower power levels for beam intensity, Genta found that an inflated sail essentially holds its shape under beam power, using a 1 meter diameter sail at 30 G's acceleration. Further testing at increased power levels, approximating Starshot, are ahead, and key questions now come up, including whether hitting a sail with 30,000 G's will not both deform and spin the sail. This is something Jim Benford reminded me of. Although, as Giancarlo Genta pointed out, the sail could be abandoned for the duration of the cruise if it can be brought up safely to speed in the first place. Now, I heard several people in the audience calling communications back to Earth the biggest challenge for Starshot, and although Dr. Fugate might disagree, I have to say that David Messerschmitt's talk on data return was sobering. We have to make up 7 orders of magnitude of signal power when compared to our outer solar system missions, perhaps a doable proposition if we can allow decades for data return. And we also deal with formidable issues of background radiation, issues of pointing accuracy, atmospheric turbulence and scattering, and optical losses. All these factors push us on an increase into aperture areas like 500 plus meters. Our communications and imaging discussion, though, also takes in Slava Turishev's contributions on imaging an exo-Earth with the solar gravitational lens. Clearly, getting a good idea of our target from a technology that could allow images of 1,000 by 1,000 pixels would be an outstanding precursor in its own right, and one that could be used at distances up to 30 parsecs if we can make it work. Jeff Landis' reservations about the gravity lens don't question its potential, but do ask us how likely we are to make it work and deliver genuinely useful information. We got into all these meetings at the Sagan session on the 550 AU mission that Claudio Maccone has christened Focal this afternoon, where Landis, Turyashev, Greg Matloff, and Pontus Brandt debated the issue. It should be kept in mind that some of Maccone's recent work on the lens has shown some potential for communication. And if this could be realized, it could suddenly turn many of the issues David Messerschmitt examined on their head. Thus, if it could be determined a lensing option is workable, an early Starshot mission to explore this region is a possibility. Consider me a skeptic along with Jeff Landis, but I am all for, of course, the continued research that is being done, and who knows what we're going to learn through this good work, especially at JPL. Let me mention, too, the Sagan session on detecting life through biosignatures in planetary atmospheres, in which I spoke along with Greg Benford and Angel Tanner. This is by way of looking at what we can learn about nearby stars, the fact being that nearby red dwarfs are going to be under intense scrutiny by the James Webb Space Telescope, and we have the possibility of detecting gases like oxygen and methane, which, if found together, offer us a strong indicator of some kind of metabolism. Tanner's analysis of planet-finding techniques in a later session took us through the range of methods available, ranging from radial velocity to direct imaging and transit, particularly in terms of distinguishing stellar noise from terrestrial mass planets. And that's a big issue, stellar noise in all of this kind of exoplanetary work. We moved into the realm of other interstellar precursor missions with Pontus Brandt's discussion of probe missions to 200 AU up to 1,000 AU. This gets us into virgin territory, for going to this distance puts us into the relatively pristine interstellar medium. Quaward lines up as an interesting target along the way because of what it may tell us about the KBO population, and the great success here is that I pronounced Quawar properly. Very difficult if you look at the spelling of this KBO. But we would also learn a great deal about dust distribution within our system with such a mission, seeing the heliosphere from outside as we see similar astropheres around other stars. Brandt's comments on how we manage long-term missions ring true in an era of decadal data return from a Starshot mission and destinations that may require more than a single human lifetime. Gary Pager's take on precursors would use the Princeton Field Reversed Configuration Machine to reach out to that magical 550 AU target where the lens effects begin to become available, with a mission time of 13 years or 18 if we choose to stop. Using this technology, an Alpha Centauri flyby becomes feasible within 550 years, with both power and propulsion generated by a single engine. And even that, when you compare to what we were looking at just a few years ago, is an astonishingly quick journey. Can we do Centauri with a solar sail mission? Olga Starinova asked that question, noting a close solar flyby based on recent studies by Greg Matloff, Les Johnson, Claudio Maccone, and Roman Kezarashvili to reach the inner Oort cloud within 30 years. And Stacy Weinstein-Weiss discussed a key interstellar question. Why is science return from an interstellar mission necessarily better than local studies from the Earth? Here we learned about the unique science measurements that would be performed en route to the exoplanet, including the outer regions of our own solar system, the Oort cloud, local interstellar medium, and the astrospheric environment around the host star. Perhaps trumping all of these is the search for life with in situ measurements. Richard London and James Early helped us to understand the dust impact hazard, which, interestingly enough, they believe will not threaten a sail itself. But of course, our concern is likewise with our payload. Here, we must protect it at all costs. London and Early used the Hydra code for inertial confinement fusion in this work to study how we might reduce risks using optimal materials on a fast-moving craft's leading side, with leading thin foil to animize dust grains. Robert Freeland pointed out to me that one of Jeff Greason's plasma magnet sails, which I'm going to discuss in a minute, could actually serve possibly as a useful shield in this regard for dust mitigation. On useful precursor technologies, Sandy Montgomery provided a way to avoid growth in the boom diameter and mass of sails as we move toward larger scale missions by using what he calls a space tow architecture, a train of gossamer sails integrated with a tension truss column. Here, the advantages are we get much larger sails without growth in boom diameter and mass, using lightweight longeron filaments to connect a stack of smaller sails, much like a tandem kite. Well, I'd mentioned to Pete Worden in a recent online exchange that I'd seen several small sail analyses springing up and asked him if these had any connection with Breakthrough Starshot. His answer was that they did not, but as he put it, well, the more the merrier, given the magnitude of our problem. So the more help we can get on this, the better. And so it's tremendously heartening to me to see the outgrowth of sail ideas that may eventually influence Starshot, or more likely, feed into designs outside of immediate interstellar goals that could play into our move toward a space-based infrastructure that we need here in our own system. Thus, Grover Swartzlander's analysis of diffractive metasailcraft, which proposes that we look more carefully at diffractive sails, which absorb little light, a key issue for beam sails, and have none of the re-radiation problems of reflective materials. Moreover, we might learn to recycle photons to multiple sail layers if we can develop the right broadband, space-qualified diffractive films. TVIW 2017 was marked by its focus on sail technologies due to all the factors I've already mentioned, but of course we have many other options to consider. Jason Cassibri talked about the problems of solid-state nozzles when dealing with pulsed fusion and fission-fusion hybrids for rapid precursor missions. The primary issues being erosion, wall heating. He showed 3D plasma simulation of a pulsed magnetic nozzle crafted for Z-pinch propulsion. Paulie Lane examined fission fragment possibilities, given the fact that uranium fission releases 81% of its energy in the form of kinetic energy, which I did not realize. The escape of fission fragments rises when particle size decreases, so low-density fissile material like americium or curium comes into play, with the escaping fission fragments being used as rocket propulsion. As Lane noted, fission fragment advocates also have to contend with fuel production, how to produce enough of the needed materials, as well as daunting issues of using such rockets safely, and we'll return to that question in a moment. Antimatter appeared in 2 sessions this year, with Gerald Jackson describing crowd-funded ongoing experimentation into antimatter production. Jackson would like to see antimatter emerge at a rate of at least 1 gram per year. That's a startling figure given, well, I can remember when NASA gave a figure of 62.5 trillion for a gram of antihydrogen. So quite a bar to cross. Measure this too against a Fermilab reduction rate of 2 nanograms per year. If we can do this in a way that is economically feasible, we have the option of missions like the antimatter sail that Jackson and Steve Howe, also at H-Bar Technologies, has developed through NIAC work. Jackson also examined antimatter storage possibilities through diamagnetic levitation. Antimatter storage was the key of Mark Webber's talk, which looks at the problem of controlling space charge, the repulsive force of all those stored charges in the fuel we would like to use. Webber is experimenting with storing electrons in a massively parallel microarray of tubes in a 7 Tesla magnetic field, seeking to discover the possible configurations in trap arrays. Everyone in the interstellar community, from Les Shepard and Robert Forward on, has pondered the energetics of antimatter rockets, which still face the daunting storage and production issues Webber and Jackson have explored. But my goodness, what we could do with that antimatter if we can produce and store it. Now, a bit less exotic perhaps, but with exciting potential of its own, is the plasma magnet sail described by Jeff Greason. Here we can imagine deploying mag sails for braking against the interstellar medium as an interstellar probe enters a destination system, perhaps achieving orbit around the target star using the stellar wind. But, and this is interesting to me, Greason pointed out, such technologies are likewise ideal for precursor missions to 1000 AU. Conceivably, using local beamers, we could use these as braking systems for fast missions inside the solar system, including cycling system to Mars. That's near-term stuff that's very exciting. Greason also considered using particle beams and even fusion pellet delivery to the sail. I should mention that a Sagan session also explored flyby versus deceleration with the help of Jackson, Stacy Weinstein-Weiss, and Gerald Jackson, along with David Messerschmidt. I meant to say Al Jackson. Both Jacksons were at that session. The deceleration problem is just huge and continues to be so. If we do get Starshot probes to Proxima, the imagery we get back may well make clear the need for a sustained presence in that system. The payoff, as Weinstein-Weiss made clear, would be in the search for extraterrestrial life, where we may need all the resources we can muster to verify a detection, and think how hard it is even here on Mars to make this detection. Talking about interstellar mission concepts reminds me inescapably of a loss we suffered this year in science fiction writer Jerry Pournelle. I think he's familiar to most of us here. Jerry explored numerous interstellar schemes, including beam sails, early on. And in Footfall, he even used the Orion technology to save the species. Quite a read. Because Larry Niven wrote Footfall with Pournelle, I want to mention how pleased I was to be able to shake his hand at long last. Larry brought a whole new dimension to my science fiction reading back in the 1970s with short stories and novels like Ringworld. What a compliment to TVIW to have Larry, along with writers Jeff Landis, James Cambias, Greg Benford, and Alan Steele here for tonight's writers panel, not to mention our host, Les Johnson himself. About Steele, I do want to say I've read Arkwright twice now, and if you don't know this novel, you need to acquire a copy immediately, as it addresses the issues a small community of devoted advocates face when trying to do something as outlandish as build vehicles that could move between stars. Highly recommended. The valedictory theme, unfortunately, continues. Let me also mention this year we lost Jordan Kerr, an innovative physicist who came up with ideas like sail beam, a stream of microsails delivered to a receding starship as a form of propulsion, and the Bussard buzz bomb, as he called it, a starship that came up to speed through collision fusion with a string of pellets that had been fed out on a predetermined track. I never met Jordan, but I spent a lot of time on the phone with him when I was writing my Centauri Dreams book. I think the field is diminished by his passing. The infrastructure theme emerged several times at this year's sessions, with Tracy Prater looking at NASA's in-space manufacturing project under the theme, Make It, Don't Take It. And it only makes sense as we contemplate long-term manned missions that we look at manufacturing and recycling parts on demand, using the ISS while we still can. We learned about NASA's plans for a multi-process fabrication factory called Fab Lab, with current experiments on the ISS pointing to a robust future for assembly of materials in space with 3D printing technology. John Barr told us about the United Launch Alliance's robust work with ACES, Advanced Cryogenic Evolved Stage, and Zeus, a vertical landing, vertical takeoff lunar lander demonstrator. Can we use these refuelable, reusable technologies in company with the Vulcan booster to establish what will become trade routes to cislunar space? The idea here is connecting low Earth and geostationary orbits with Earth-Moon L1 and the lunar surface, with the goal a robust solar system economy, which will eventually translate our early interstellar precursors like Starshot into a longer-term framework of exploration and perhaps colonization. Our leadership panel this morning included John Culberson, whose language we've already discussed regarding a NASA inquiry into interstellar prospects to coincide with the anniversary of the moon landing in 2069. Also, Congressman Brooks of Alabama, Lieutenant General Quast, and Paul McConaughey, who directs Marshall Space Flight Center. It was rousing to hear the energy of Representative Culberson as he described Europa Clipper. That certainly woke me up beyond my coffee level this morning, and I was glad to hear that. And the possibilities of the space launch system that we also learned about. A takeaway was Culberson's belief that the discovery of life, either in our system at Europa or Enceladus, or around another star through biosignatures, will be the civilization-changing discovery that ignites public support for future exploration. And just as a personal note, I will bet you we find life around another star, at least biosignatures, before we ever find it here. I think we're going to be in a realm of ambiguity here for decades. Conceivably, we could find a biosignature within 10 years, perhaps 20. I think we're going to find it out there first. It was sobering to consider the budgetary dilemmas of ever-rising deficits and accumulating national debt. Lieutenant General Quast emphasized that expansion into space demands we take our values with us even as we plan missions to ever more distant targets. The panelists' responses to Pete Klupar's concern over installations like the Starshot 100-gigawatt laser show me that we still have many policy questions to answer as private initiatives like these go forward. Clearly, these caught our panelists, I think, somewhat flat-footed because this policy question is a long way from resolution. So, can we get beyond bureaucracy and current cultural fatigue to expand the realm of values responsibly? Brent Zarnick reminded us that interstellar technology presents us with the most daunting energies human beings have ever thought of developing. The analogy with nuclear energy is clear and fortunately supported by deep scholarship. Our preoccupation with nuclear gloom, part of Sheldon Unger's dynamic oscillation that Zarnick described, ended Project Orion and threatens our development of nuclear power options as a positive tool for exploration, and we're going to need those power options in the outer system. Is METI likewise an ethical issue? Kelly Smith asks whether scientists are really the ones to be answering this question of broadcasting to the stars, given that this is a matter that potentially involves the entire species. Yes, the risk is small. We believe it is low risk, but the risk is not zero. And the risk involves nothing less than the survival of our planet. Or what about the ethics of seeding humans out into space, sending them to the stars? For we may discover that exoplanets themselves are not empty, and given the fact that we use but 21 specific amino acids to build our proteins, and that there are many more naturally occurring amino acids, we cannot know what life may choose to use. Perhaps, as Ken Roy reminds us, we might look for lifeless worlds on purpose, seeking places we can terraform as our primary destination. So now we're in the realm of issues among the stars, humans actually far from Earth, a future that could involve vast world ships taking human populations to distant systems, generation ships, or Corin discussed the vital question of how we reduce conflict in a closed environment in which causes of violence are numerous. Corin used large data sets to look at historical examples of violence, along with strategies by which we might reduce problems like a lack of external ideas and migration. The result, our world ship may emerge as multicultural and semi-centralized, a hybrid of Sweden and Singapore. James Schwartz worked similar turf, but examined the ethics of world ship travel itself. Are colonists on dubious ground imposing a world ship future on their children? Perhaps not, but the real question becomes, should we put parents on world ships in the first place? Schwartz reminded us of the need for sufficiently large crews and the fact that we will use extraterrestrial settlements much closer to home to learn valuable lessons before embarking starward. So, there we are, TVIW 2017. I thank you all for the opportunity to listen to and learn from your deliberations. If there's one thing that the interstellar community has taught me, it is that scientists working at the top of their form are willing to take time, listen to questions, and explain their work to writers like me, and to put breathtaking concepts out to a receptive and growing audience like those who gathered here. This is a mission that all of you make possible, and while it may seem less dazzling than a starshot, it is vital in making our interstellar effort a planet-wide affair. So I close by returning to Lao Tzu. To avoid disappointment, says the Tao Te Ching, know what is sufficient. To avoid trouble, know when to stop. And I'm done.